Hello, dear students. I hope all of you are safe. It's time to Nuclear Chemistry Lesson 4, Nuclear Reactions. Nuclear reactions are changing the structure of reactant nuclei and forming a new product nuclei when the nuclei of reactants collide with each other. Chemical reactions occur via the electrons of outermost energy level of atoms while the nuclear structure doesn't change. Nuclear reactions consist of four reactions: natural transmutation, artificial nuclear reactions, nuclear fusion, and nuclear fission reactions. Number one, natural transmutation. Natural transmutation occurs of nuclei whose ratio between protons and neutrons is greater than ratio required for stability. Example number one, on natural transmutation. To achieve stability, uranium-238 nucleus emits alpha particles turning into thorium-234. Uranium-92-238 is converted to thorium-90-234 plus alpha particle. Note, the mass number of uranium atom equals the summation of mass number of thorium and alpha particle. Example number two, to achieve stability, the unstable isotope of carbon-14 emit beta particle turning into nitrogen atom. When a nucleus emits beta particle, a neutron turns into proton, which increase the atomic number of nucleus. Mass number of beta particle is 0 because its mass is negligible if compared to mass of proton or neutrons. Number two, artificial nuclear reactions. If we want two nuclei to react with each other, we accelerate one of them to get high energy, then we target it at the second nucleus. The accelerated nucleus is called projectile, while the targeted nucleus is called target. Nuclear reactions. Example of nuclear projectile: protons, neutrons, and alpha particles. Nuclei are accelerated by device called nuclear accelerators. For example, Van de Graaff accelerator and cyclotron accelerator. Rutherford and first artificial nuclear reaction. In 1919, Rutherford carried out the first nuclear reaction in history when an alpha particle passed through nitrogen. It formed the nucleus of fluorine. This fluorine nucleus is a compound nucleus. A compound nucleus is an unstable nucleus with massive energy. Compound fluorine nucleus gets rid of excess energy by emitting a proton, which turns into oxygen-17 nucleus. Examples on artificial nuclear reactions such as aluminum, magnesium, and lithium. When balancing nuclear equations, we should subject to conservation laws of a charge and energy. Conservation law of a charge: the sum of atomic numbers on the right side of nuclear equation should equal the sum of atomic numbers on its left side. Conservation law of energy and mass: the sum of mass numbers on the right side of nuclear equation should equal the number of mass number on its left side. Number three, nuclear fission. Nuclear fission, a nuclear reaction in which a nuclear splits into nuclei. Example, when a neutron bombards uranium-235 nucleus, it enters the nucleus, turning it into an unstable isotope called uranium-236. Neutrons don't need to be accelerated because they are neutral. Projectile can't be affected by charges in nucleus. Uranium-232 splits within 10 to 12 seconds into 2 or 3 neutrons and 2 nuclei X and Y. Those 2 nuclei are called nuclear fission fragments. 90 different fragments can be formed from such a reaction. Uranium plus neutron give uranium to 236 and split it into 2 or 3 neutrons and 2 nuclei X and Y. Nuclear fusion, number 4, a nuclear reaction in which 2 light nuclei join to form a heavier nucleus. Example, when 2 deuteron nuclei fuse together, they form helium nucleus plus neutron plus energy. H12, 2 deuterium nuclei join together to give helium nucleus plus 1 neutron plus 24 MeV, million electron volt. The difference between the mass of helium and that of 2 deuteron nuclei transforms into energy. Requirements of nuclear fission: very high temperature that may reach 10 million degrees Celsius. It's hard to carry out nuclear fission reactions in laboratories because they require very high temperature. Nuclear fusion reaction occur in stars such as sun to produce energy because of their high temperature. Nuclear fusion is a source of destructive power of hydrogen bomb. We say that nuclear fission reaction produce a group of neutrons and nuclear fragments. If the speed of produced neutrons is suitable, they will be able to split more uranium-235 nuclei and so on. Such reactions are called chain reactions. A chain reaction is a continuous split of uranium nuclei. Chain reactions produce high heat energy which increases as reaction goes on. Chain reactions are basis of nuclear fission bombs. This is chain reaction that occurs in nuclear reactor. Uranium, its target, and the projectile of neutron to give two fragments by 1 neutron or 2 neutron give other fragments. This is called a chain reaction. Critical mass, the smallest amount of fissile material needed of uranium needed for sustaining nuclear chain reaction. In critical mass of uranium, every nuclear fission reaction produces 1 neutron in average, which being another fission reaction. Therefore, a chain reaction goes on with the same initial rate at the beginning of reaction. If an amount of uranium of mass greater than critical mass is used, the reaction goes on with fast rate, which causes the occurrence of explosion. This required for the manufacture of nuclear fission bombs sometimes. Cadmium rod and control the chain reactions. Control rod, mainly made of cadmium, are used to control chain reactions in nuclear reactors. They control the number of neutrons by absorbing them, which prevents the occurrence of explosion and produce energy. When putting cadmium rod inside the reactor, they slow down chain reactions. We can change the rate of reactions by controlling the position and the number of cadmium rod. Comparison between chemical and nuclear reactions. Chemical reactions that occur via electron inside in the outermost energy levels. Nuclear reactions, they occur via components of nucleus. Chemical reactions, they don't change an element to another one. Nuclear reactions are usual associated with a change of element to another one or isotope. Chemical reactions, products of reaction don't change by the change of isotope of element. Nuclear reactions, every isotope of element gives different products. Chemical reactions gives out low energy. Nuclear reactions gives out high energy. Peaceful use of radiation. In medicine, gamma rays emitted from cobalt 60 and cesium 17 isotope are targeted to the center of cancer or cancerous tumor to kill cancer cell. Radioactive radium-226 needles are implanted into cancer tumors to kill their cells. Industry, gamma rays are used in automatic control of some product lines. Automatic control of pouring molten steel, such as automatic control of pouring molten steel. Source of gamma rays, cobalt 60 or cesium 17, is put on one side of pouring machine, and radiation detector, which receives gamma rays, is put on the other side. When the mass of steel reaches certain dimensions, the detector becomes unable to receive gamma rays, which stops pouring molten steel. Agriculture. Number 1, seeds are exposed to different dosage of gamma rays to help in the occurrence of mutation in them, choosing suitable seeds which give out more producing and more resistant plants. Number 2, gamma rays are used to sterilize plant and animal products which protect them from damage, extends their storage periods. Number 3, gamma rays are used to make male insects in fertilizer to prevent the spread of pests. Scientific research reactors are used to prepare radioactive isotopes which are being used in scientific research. For example, water with radioactive oxygen isotope is put in plant to know its path. Harmful effect of radiation. There are two kinds of radiation, which are ionizing radiation or non-ionizing radiation. Ionizing radiation which changes the structure of tissues. It penetrates. It ionizes atoms when it hits them. Example, alpha particles, beta particles, gamma rays, and X-rays. In non-ionization radiation which doesn't change the structure of tissues, it penetrates. Examples, radio waves emit from mobile phones, microwave, light, and infrared waves. Number 5, ultraviolet waves and laser waves. Harmful of ionizing radiation. When ionizing radiation hits a cell, it ionizes water molecules in it, which causes the damage of cell, occurrence of genetic changes, and breaks up chromosomes. Water is the main component of cell, so when water molecules ionize, they damage cell body. In long term, effects occur in cell which cause the death of cell, delay or prevention of cellular division, or the increase of cell division rate which cause cancer tumors. The occurrence of permanent changes in cell mutation which are inherited to the offspring, which cause the appearance of new babies different from their parents. Harmful of non-ionizing radiation. Number 1, radiations emitted from mobile towers cause physiological changes to the nervous system. Thus, people who live near mobile tower suffer from headache, memory loss, and sickness. Number 2, the electric and the magnetic fields of radio waves which are emitted from mobile phones increase the temperature of cells because they absorb energy. Number 3, putting laptop on knee affect the fertility of men. Dear students, it's the end of lesson. I hope you understand it. Bye.